Okay, so here we have a practice. Practice is we start with this monomer, right? So the monomer is basically the name for it is 15-hydroxy penta, which 15. Decanoic acid means the number of carbon is 15, 14 here, 1 here. Then the polymer we're going to make is from the same monomer. So this hydroxy acid is going to be used to make the polymer. So we're asking basically if we want to make a polymer which 24,000 gram per mole as molecular weight, average molecular weight, what should be the conversion of these monomer to each other? 60%, 80%, 90%, we don't know. But before making the polymer, we're going to look into this and see what's the conversion is going to be. Now, it says we're going to ignore the end group. So I have a little slide later on for the end group. What's the significance of the end group? So hold on for that for a second. So let's look at what we're making here. So we try to make a polymers, right? So the same problem up here. So the polymer that we're going to make, let's start with 2 molecules or 2 moles of these 2 monomers. Remember, this is an acid and this is an alcohol. So when we add acid and alcohol together, we're forming an ester group. We're losing 1 water molecule, and that forms an ester group. Again, the ester group, still the first ester group, which is N equals 1, has a carboxylic acid and has the alcohol. So that reaction continues to make the monomer that we're looking for. Make the polymer that we're looking for. So the polymer that we're looking at is now the mer, or the repeating unit is OCH2 14 times CO. And then one end group, again, remember we're talking the end group is OH from this carboxylic acid. And one end group is OH, one end group is the H from the other end group. So we have from the OH. So we have 2 end group, the repeating unit. Now let's look at some paper. I made some little paper. So the paper, I want to make sure that we represent one of the molecule with this pink and one molecule with the white. So I guess it's pink. I always forget the color. So we have reaction this pink and white together, and that's how the monomer become a polymer. So let's look at this paper thing I did. So we have 1, 2, 3, 4, 5. So 5 of these monomers react with each other to form this polymer chain. So we're looking at 24,000 of them. So let's obviously, if I want to make it 24,000, I have to use many papers. But let's say the N for this would be now 1, 2, 3, 4, 5. And how we're going to measure the molecular weight for that. And the N group is missing from this. N group is missing from this. Again, if I go to unit for this 2 or 3, so the unit or the mer repeating unit would be O CH2 14 C double bond O. This takes a little bit of practice to look at these 2 monomer and decide when they react to make the ester group, which part of that ester group or molecule we're going to look and use as repeating unit. It takes time, but I know we can practice and practice. So what we're going to do for this problem, we need a couple of things to remember. One of them is a dp hat or xn hat. Now, different textbooks, they use different notation. At the Stevens book, and most polymer chemistry book that I exposed to or learn or read, they use dp hat. The hat actually means average. So dp means the repeating units. How many units gets repeated? Or textbook by Professor Young, he is using xn hat. So they are the same thing. And to be honest with you, I'm more familiar with, or happy with the dp hat, but let's use both of them, dp hat, xn. We know that the dp hat or xn hat is total average molecular weight over 1 unit of the repeating units. And that gives us the n. Remember, the n is the repeating, average repeating units. There is something new that we're going to learn, especially for step polymerization, that dp hat or xn hat is 1 over 1 minus p. This is very important formula because it tells us for certain n that we have to calculate or make the polymer, what percent conversion should be. And we talk about it, and we say that percent conversion has to be very high to make a good polymer. So let's look at that. Again, back to our little problem. So our problem is starting with this hydroxy carboxylic acid. First, we need to know what is the M0. So M0 is basically the molecular weight for the repeating unit. I should not say monomer. I should say the mer, or repeating unit. Sometimes that's not the same. So I changed that. So it shouldn't be monomer. It should be mer or repeating unit. And what is the dp hat? Of course, Professor Young using xn hat. And what is the percent conversion? What is the percent conversion? Again, when we start with the monomer, and repeating unit is different than the monomer we have here. So the repeating unit is actually O CH2 14 times CO, and then goes through the bracket. So this is a repeating unit. So repeating unit has a different molecular weight than monomer. So how many carbon we have? 14, 28 hydrogen, and 2 oxygen. So that makes it 240 grams per mole. So at this point now we can go and calculate dp hat or xn hat by knowing that the ratio of m and mn hat over m0 is dp hat. So my dp hat would be 100. Once I know what the dp hat is, I know the dp hat is 100. I want to repeat this polymer 100 times. So now I'm going to use the other formula, dp hat or xn hat is equal to 1 over 1 minus p. So for what I'm looking for is actually the little p. So the p xn, if I use xn, times this, xn times p, equal 1. So p percent conversion is going to be 1 minus 1 over xn, 1 minus 1 over 100. So the p has to be 99.999%. So it's amazing. It's amazing when you look at the polymer. So I really need 99.9% conversion for this monomer to react with each other to form a molecular weight of 24,000. Really high percent yield, high percent conversion. Monomers have to be very clean. The vessel has to be clean. And we have to have patience to make sure that we do get to 99% conversion. So again, what we did and what we use is formula. This formula is very important. dp hat or xn hat is 1 over minus p. Again, what is p? So p is conversion. So if I want this would be 100, so the P has to be 99.999%. Thank you.